let's take a look at this problem. And our instructions are to minimize according to the constraint, not restraint. Step 1, take the constraint equation and get 0 on one side. So 2x plus 3y equals 65. Take 65 over. And we got that solved for 0. Now this is our g of xy. Step 2, I'm going to create a new function, f of x, y, lambda is going to equal to our initial function, the original function, so f of xy plus lambda times g of xy. So f of xy is x squared plus y squared plus lambda times what we said g of xy was here, which is 2x plus 3y minus 65. And that's going to give us x squared plus y squared plus lambda times 2x is 2x lambda. Lambda times 3y is 3y lambda. Lambda times negative 65 is negative 65 lambda. Step 3. We want to find fx, fy, and f lambda. Now this is a notation here is the partial derivative. What that means is we take the derivative just like normal, but with respect to a variable. So here we're going to take it with respect to x. What that means is x squared becomes 2x. Now we're taking with respect to x, and this is y. So this is treated as a constant, and derivative of a constant is 0, so it drops away. This one has an x, so 2 and lambda are both constants, so that becomes plus 2 lambda. This does not have an x, so it drops away. This does not have an x, so it drops away. Now if we take our partial with respect to y, all the other variables are constants. So the x squared here is a constant, so it drops away. Derivative of y squared is 2y. This does not have a y, so everything here, all these variables are constants, so the derivative of a constant goes away. Here we have a y. The lambda is a constant, so the derivative of y is 1, so we've got 3 lambda times 1, or 3 lambda. And this does not have a y, so it drops away. Okay, now our partial with respect to lambda. You could go through and find it here, but really it's always g of xy. So that's 2x plus 3y minus 65. Has to be. If right up here this is lambda to the first power and times this, then when you take derivative of lambda it goes to 1, and 1 times this would give you 2x plus 3y minus 65. Step 4. We're going to solve fx and fy, our partial of f with respect to x, partial of f with respect to y, fx and fy for lambda. Okay, so these two equations right here, I got 2x plus 2 lambda equals 0. And I'm also going to have 2y plus 3 lambda is equal to 0. I didn't say that, but you should set them equal to 0. This is like version 1. So set these both equal to 0. And solve for lambda. So over here, I take 2x over, becomes a negative 2x. Divide both sides by 2, and we get lambda is equal to negative x. Here, I take 2y over, becomes a negative 2y. Divide both sides by 3, and you get lambda is equal to negative 2/3 y. Then set these equal to each other and solve for y. What that means is since both of these are now equal to lambda, I can set the right sides equal to each other. So negative x is equal to negative 2/3 y. Divide or multiply both sides by negative 1, and you get x is equal to 2/3 y. Multiply both sides by 3, and you get 3x equals 2y. And then divide both sides by 2, and you get y is equal to 3/2 x. Step 5. Plug this into f lambda. Now f lambda is right here. And I should have said that you set this equal to 0 too. So we now know what y is. Y is 3/2 x. So you got 2x plus 3 times 3/2 x minus 65 equal to 0. 2x plus 3 times 3 is 9, so we got 9/2 x minus 65 equal to 0. Multiply everything by 2, and you get 4x plus 9x minus 130 equals 0. That gives us 13x. Take negative 130 over, it becomes a positive 130. And we get x equal 10. Okay, that's step 5. I didn't label it though, did I? Step 5. Step 6. Plug the values from step 5 into one of the equations from step 3. Once we got them equal to 0, that is. Okay, I'm lying. Plug it in here. Step 4. I came up with these steps just a little bit ago, so this is still version 1. Okay, so plug this into this equation here. So we got negative x equals negative 2/3 y. Plug 10 in. Multiply both sides by negative 1. Multiply both sides by 3. And we get 30 is equal to 2y, which gives us y is equal to 15. So we got x is 10, and y is 15. Now this is our critical point. So from here we plug this into the objective function f of xy. Largest is your max, smallest is your min. They already tell you it's a min, so they give you that information. Now we're plugging this back into f of xy, which is x squared plus y squared. So x squared plus y squared gives us 100 plus 225, which gives us an answer of 325.